Hello friends. So we were discussing about distance time graph and we have discussed two cases in the distance time graph. That is, one is when the object is at rest, when its position is not getting changed with respect to a reference point. Okay, and in that case we have seen the graph that is drawn, that is the distance time graph that is drawn using this kind of situation is a straight line. It's a line which is parallel to horizontal, or we can say the x axis, or we can say the time axis. Okay, because on the x axis or the horizontal axis we used to plot the time. Okay, and in the second case we discussed about the distance time graph of a body of an object which is performing a uniform motion. So in case of uniform motion we have seen that the distance time graph of that object is a straight line which is inclined to the x axis or the horizontal axis at some particular angle. We also discussed that if this angle is increased or if this angle is more, then using that angle we can calculate the velocity of the object. We have seen a term, we have defined a new term which is known as slope, or we defined it in other way as tan theta. And as I told you that velocity is equals to tan theta. So more the angle, more the velocity, less the angle, less the velocity. So it means using the distance time graph I can calculate the velocity of an object. Okay, it would be easy for me to calculate the velocity of an object using the distance time graph by just calculating the slope. Slope means the tan of theta. Theta is the unknown angle. Okay, you will learn this about trigonometry, this tan theta in your trigonometric concept in trigonometric course. Okay, so let's continue our topic with the discussion of distance time graph. In distance time graph we have completed stationary, the distance time graph of a stationary object, then uniform object, and the third case, that is case number C, that we have to discuss is distance time graph of a body, or let me write it in the same way as we have written in the previous cases, when the body is in non-uniform motion. When the body is in non-uniform motion, we will discuss that kind of case, and through that case we will understand some more interesting terms. See, if the body is performing non-uniform motion, what exactly is meant by non-uniform motion? We discussed earlier that when an object, when a body travels unequal distances in equal intervals of time, we call that kind of motion as non-uniform motion. Okay, so let's assume that this is the reference point A, and from this point an object starts its motion. Okay, the object is traveling in a straight line and it started its motion from this point A, and let us say it moved to point B. Let's say it moved to point B in 1 second, and let's say it traveled around 100 meters. Okay, I assume that there is an object which is at point A. It started its journey from point A and moved to point B, that is 100 meters in 1 second. Now let's say in another 1 second, in the next 1 second, let's say it moved to point C, which is at 80 meters away from point B. Okay, then after point C, let's say it moved to point D, which is in 1 second it's moved to point D, which is, let's say, 60 meters away from point C. Okay, and then from point C, let's say it moved to point E in 1 second, which is at 40 meters away from point D. See, so what I have assumed, I have just taken an object which is traveling 100 meters in first 1 second, then 80 meters in next 1 second, then 60 meters in next 1 second, then 40 meters and so on. So this is just an example that I have taken. You can see the time interval that I am considering is 1 second, that is equal time intervals, and the distance travelled or the displacement that I am taking is 100, 80, 60 and 40, that is unequal distances. So it means definitely according to the definition of non-uniform motion, this object is performing a non-uniform motion. Okay, so it's definitely performing a non-uniform motion, and let's try to write this data in a tabular form. Okay, let's try to write this data in a tabular form. What I can say is, this is the time and this is the distance. So what I am considering is at t is equals to 0 seconds, this is at t is equals to 0 seconds, then after 1 second it is at t is equals to 1 second, and then after this 1 second it is at t is equals to 2 seconds, then at point D it is at t is equals to 3 seconds, and then this is at t is equals to 4 seconds. Okay. So we have assumed that object is travelling in a straight line, and in every 1 second the object is travelling some distance which is not equal to the previous distance. So that's why the table that we can make is at 0 second it is at 0 position, that is initially the reference point is point A and the object is also standing at point A only. So when I started observing the object, it was at point A, which is my reference point. So definitely if the object is already at point A, the distance, its initial distance from the reference point is 0. Okay, that is we have taken as 0. Then after 1 second the object has travelled 100 meters. Okay, like this. The object has already travelled 100 meters, and then let's say in the second 1 second, this one, you can see the total time from A to C is 2 seconds and total distance is 180 meters, because in the next 1 second the object has travelled 80 meters, so it is 180, and then in the next 1 second the object has travelled 60 more, so 80 plus 60 plus 100 it will give you 240 meters. Then in the next 1 second the object has travelled, or let me write it here, 2 seconds, and then 3 seconds, and then 4 seconds. The object has travelled 40 further and it is 280 meters. So this is the distance travelled by the object in 4 seconds that I can write in a tabular form. Okay. Now it's clearly seen that object is travelling in a non-uniform motion. So can't I draw the distance time graph? No, there is no foundation in drawing the distance time graph. I can definitely draw the distance time graph of this particular data. And how will I draw the distance time graph? I need to put distance on the y-axis and time on the x-axis. So let's try to draw the graph. Let's try to plot this condition that we have written here. This is time is in seconds, and then this is distance, that is distance is in meters. Okay, so this is the distance, this is the time. Now let's plot the time and distance. This is 1 second, this is the 0 seconds or 0 meters, this is 2 seconds, this is 3, this is 4, and so on. This will get continued. And similarly, so we have to plot this 0, 180 and 240 and so on. So let's make it like this. This is, let's say 20, or let me make it small. This is 20, this is 40, this is 60, this is 80, this is 100, then 120, 140, 160, and 180, then 200, and let's increase the length of this y-axis. This is 220, this is then using the same, this is 240, and then increasing it further. So this is 260 and 280. So this is 260 and this is 280. So we have marked the point till 280. Okay, the 280 meters. So what I can see here, that is in first 0 second the object was at point A. So how can I mark the point A? This location will show the position of object. This is the point A. Okay, because the object haven't traveled any distance in 0 seconds. When I started observing the object, it was already at t is equals to 0, and that is at d is equals to 0, distance is equals to 0. Now after 1 second the object has travelled 100 meters. So where is the 100 meters? This is the 100 meter and this is 1 second. So the position of point B on this graph would be this one. This is the position of point B on this graph. So this I marked the point B. Now after 1 second, in the next 1 second the object has travelled 80, that is in 2 seconds the object has travelled 180 meters. So in the 2 second I have to plot 180 meters, this is 180 meters and this is the 2 seconds, something like this, and this is the point C. Okay. So after 2 seconds the object is at point C. Now after 3 seconds the object is at point D, and point D means 3 seconds it has travelled 240 meters. So at 3 seconds I have to plot 240 meters like this and something in this manner, and this is point D. Okay, this is the point D. When object has travelled for 3 seconds, it has reached point D, that is 240 meters. Then after 4 seconds the object has reached 280 meters. Object has travelled the 280 meter distance and it is finally at point E. So in this manner I will draw. This is the 4 seconds. And like this. So this would be the point E. Okay, so this is our point E. Now when you join these points, when you join this A, B, C, D and E, you will find a graph like this and like this. The graph will go like this. In this manner it will get tilted at this point and like this it will go. Okay, so what I can see, this graph is not a straight line. Okay, this graph, the graph is not a straight line. So it's not a straight line. Now why it is not a straight line? Because the straight line is in the case when the object is travelling a uniform motion. That is when the object has travelled equal distances in equal intervals of time. But in this case we can see the object is travelling unequal distances in equal intervals of time, that is the object is travelling in non-uniform motion. So what I can see, the graph is something curved. Okay, we call this as a curve. So how is the graph of a non-uniform motion? So using this, drawing the result from this kind of graph, we will say the graph of non-uniform motion is not a straight line, rather it's a curve. So you can see that the graph is curved like this. Okay, it's not a straight line. So this is the kind of motion which is not uniform. Now remember, a very important terminology that we have studied is the acceleration. What is basically acceleration? Acceleration is basically change in velocity in unit time. So when the velocity changes, there would be acceleration. So can you see here in this particular diagram, the object is traveling in the straight line, that is the direction of the object is not getting changed, but the magnitude of velocity is getting changed. This we have discussed in the non-uniform motion. So since the velocity is getting changed, there has to be the acceleration. So we generally call the non-uniform motion as accelerated motion. Okay, so we say here the motion is accelerated motion. Here the motion is accelerated. Now, what kind of acceleration? We studied two kind of acceleration. When the acceleration is in the direction of velocity, we call it as positive acceleration, and when the acceleration is opposite to the direction of velocity, we call it as negative acceleration or retardation. Okay, we have discussed these two terms, that the retardation and the acceleration are the two terms which is used for the acceleration only. Just the direction of the acceleration is changed and we call it as retardation. So definitely here I can see since the motion is accelerated. Now what kind of accelerated? Is it positively accelerated? Is it negatively accelerated? Or what kind of accelerated? So here from that condition has to be checked from the velocity. We can check that condition using the velocity. Now how velocity? See, we discussed that if the velocity of the object is increasing, then the acceleration will be in the direction of velocity. If the acceleration or if the velocity of the object is decreasing, then we say the acceleration is opposite to the direction of velocity. We discussed this concept that when we throw a ball from the ground and the ball rises in the sky, what we can see, the velocity of the ball will decrease. Okay, the velocity of the ball will decrease with the time, and at one point it will going to stop in the air and then it will start falling. So when the ball is going up in the sky, the velocity is getting decreased, that is there would be a retardation, there would be the negative acceleration. And when the ball is coming to the ground, the acceleration would be positive because the velocity of the ball will start increasing. So from that, using this graph also we can judge what kind of acceleration is this. So for that, let us write this condition. If velocity is decreasing, we call this acceleration as negative acceleration. Okay, or in bracket I should write retardation. And if velocity is increasing, if the velocity is increasing, what I will say, this acceleration is positive acceleration. Okay, we call this acceleration as positive acceleration when the velocity is increasing. Now here we have to check that how the velocity is getting changed. Is the velocity increasing or is the velocity decreasing? We can determine that this condition using this graph. Okay, using this graph we can determine. Now how can we determine using the graph? Just remember the concept that slope is basically the velocity. Okay, the slope of the distance time graph gives you the velocity. So how will we determine the velocity is increasing or decreasing? We will write the condition. The slope of distance time graph will suggest whether velocity is increasing or decreasing. Okay, so using the slope we will judge how the velocity is getting changed. Now how can we judge using the graph? Let's understand this. If I ask you to calculate the velocity of this object at point B, then I will draw a straight line at point B. Okay, just see this. I will draw a line which is exactly straight at point B, which is going to touch the horizontal axis. Like this we will draw a line. Okay, this is a line. Now the angle that this line is going to make with this horizontal axis, okay, will suggest you the velocity. You can see when I draw this line at point B, this is making an angle like this, which is, let's say, theta 1. We call this angle as theta 1. Okay, so the velocity of the object at point B will be the velocity of the object at B will be equals to tan of theta 1. Okay, the velocity of the object at point B will be tan of theta 1. It's very easy to understand. We discussed in the previous case. Okay, now so we have calculated the velocity at point B. This is tan theta 1. We need not to calculate the exact value or numerical value. This is just for the understanding. This is just for the concept that we have to understand. Don't go for the calculation, just focus on the concept. See, so we have calculated the velocity at point B. Now, if I want to calculate the velocity at point C, okay, my next task is to calculate the velocity of the object at point C. So how can I calculate? For that, I have to draw a line which is touching this point C and touching this curve. Okay, so like this I will going to draw a line, and in this manner I will draw this line like this. So you will find this line is making an angle, this angle theta 2. Okay, this line is making an angle theta 2, okay, with the horizontal axis. So the velocity of object at C will be equals to tan of theta 2. So the velocity of object at point C will be equals to tan of theta 2, okay, tan theta 2. Now similarly, if I want to calculate the velocity at point D, what I will do? I will draw a line at point D like this, which is touching the point D only at a single point, and this is the line, and you can see this line is making an angle of theta 3. Okay, this line is making an angle of theta 3. So what is this line? This is a line which is drawn at point D, which touches this curve at one point. Okay, that we call as a tangent to a circle or tangent to a curve, but we need not to go in that detail. Just understand that I am drawing a line which is touching this curve at a single point. I cannot draw a line like this or like this or like this, because in that case the line would be intersecting this curve. But I do not want the line to intersect or cut the curve in any manner. It should just touch the curve like this. So it will form an angle theta 3. And if I ask you the velocity at theta this point D, so the velocity of object at D, it will be equals to tan of theta 3. Okay, the velocity would be tan of theta 3. Now the most important condition you will find, observe this angle, this theta 1, it is this much. Okay, now when you observe the angle theta 2, it would have been decreased. You will find that theta 2 is decreased a bit, and then when you observe theta 3, you will find that theta 3 is, this theta 3 has been decreased with large amount. Okay, sufficient amount of decrease we can find in theta 3. And if I ask you to draw or to calculate the velocity at point D, or sorry, point E, you will find the velocity at point E would be like this. We will draw a line like this, and it will go like this, which will going to intersect at, let's say, theta 4. This line will intersect the horizontal at theta 4 angle, and the velocity of object at E will be tan theta 4. Okay. So what you will find that theta 1 is the greatest angle, then theta 2 is a bit small compared to theta 1, then theta 3 is further small, and theta 4 is the least possible angle. Okay, when you measure the angles you will find this. Okay, so how we got this result? By measuring angles. When you measure the angle using a protractor, okay, you know what is a protractor. When you put a protractor here and when you measure all these 4 angles, you will find that theta 1 is the largest, theta 2 is a bit decreased, then theta 3 is also a decreased angle, and theta 4 is the least angle. So what we understood at that time when we studied about uniform motion, that more this angle theta, more the velocity, less this angle theta, less the velocity. So that's why I can say, since the theta is getting decreased from theta 1 to theta 4, it means the velocity of the object is maximum at point B, and then it is going to decrease till it reaches point E. So it is more at point B, less at point C, then point D, and then E. So using this definition, using this conclusion, I will write velocity of the object is getting decreased. If the velocity is getting decreased, then what is happening? That if the velocity is getting decreased, then the acceleration is negative. Okay, that is the acceleration is in opposite direction, that is the object is retarding. Okay, we call this as retarding. So object is retarding when the velocity is getting decreased. Okay, so you will find a very interesting concept that when you draw a distance time graph, for example this is the distance time graph, when your graph is something like this, okay, when your graph is like this, you will say this is a straight line. So when you have a straight line in distance time graph, when the acceleration is 0, okay, when is acceleration 0? When the velocity is constant, that is the object is traveling equal distances in equal intervals of time, that is uniform motion. So here we call as acceleration is equals to 0, that is the object is traveling at uniform motion. So there is no acceleration, no change in velocity, no change in direction. Okay, now you will get a curve like this, okay, if there is negative acceleration. You will get a curve like this if there is a negative acceleration. You can see the curve, it is like this. In this curve we observed how the acceleration, how the speed is getting decreased. So that's why whenever you find a curve like this, we can say there is a negative acceleration. And when there is a curve like this, we call this as, where I can write, let's say right here, this is as positive acceleration. We call this acceleration as positive acceleration, and this is the negative acceleration, or we call this as retardation. Okay, now why this curve? Because at n number of points you will find on this curve, when you select some points and draw the line like this, you will find the angle is getting increased, and you can observe it. Angle at this point, angle is something like this, and then like this, and then like this. So angle is getting increased. So if angle is getting increased, the object is getting accelerated, its speed is getting increased. So the acceleration is in direction of velocity. So it is positive acceleration. And when the angle is getting decreased, the acceleration is negative, that is opposite to the direction of velocity, that is retardation. Okay, so this is the most important diagram which shows the motion of an object which is traveling either in uniform motion or in non-uniform motion. Okay, so this is how we can define the uniform and non-uniform motion and draw the distance time graphs. Okay, so first you note this completes our distance time graph, and after this we will discuss the velocity time graph, again a very interesting concept. So first note this, then we will continue.